Welcome to the Explainer. All right, AI is absolutely everywhere. But let's be honest, all the terms and the jargon can get pretty confusing. So in the next few minutes, we're going to cut through all that noise and build a really clear map of the AI universe, from the very basics all the way to the rise of these new autonomous agents. Let's see how it all connects.
Okay, so here's our game plan. We'll start by mapping out the big picture, then we'll get into how machines actually learn. After that, we'll look at the brain power behind deep learning, check out the whole generative revolution, and finally, bring it all home with the rise of AI agents.
So, first things first. You see these letters everywhere. AI, ML, DL. They get thrown around all the time. But how do they actually relate to each other? Let's clear up the hierarchy once and for all.
Honestly, the easiest way to think about this is like one of those Russian nesting dolls. Artificial intelligence, or AI, is the big outer doll. It's the entire field of making computers smart. Now, open that up, and inside you'll find machine learning, or ML. And then, nestled inside that, is deep learning, which is this really powerful technique that's driving most of the crazy stuff we see today, like generative AI.
So what does it actually mean for a machine to learn? It's not just some buzzword, you know. It represents a massive, fundamental shift in how we tell computers what to do.
And this right here, this is the core revolution. On the left, you've got old-school programming. We humans write all the rules. But look at the right. With machine learning, the whole thing gets flipped on its head. We give the computer a bunch of examples, the input and the output we want, and it figures out the rules all by itself. So instead of us trying to write a million rules to detect spam, we just show it a ton of emails and say this is spam, this isn't, and it learns what spam looks like on its own.
And this learning process basically comes in two main flavors. First, you've got supervised learning. That's where we give the machine labeled data. It's kind of like giving it an answer key. We show it pictures of cats that are all labeled cat. Then there's unsupervised learning. Here, we just dump a giant messy pile of data on it with no labels and just ask it to find the patterns itself. It's like handing a little kid a big box of Legos and just seeing how they sort them without any instructions.
And look, this stuff isn't abstract theory. It is literally all around you, every single day. Classification, that's your spam filter. Regression, that's what powers Zillow's Zestimate on your house. And clustering, that's how Netflix groups you with people who have similar tastes to recommend your next binge watch. Okay, that all works great for a neat, tidy data in a spreadsheet. But what about the messy stuff? You know, the stuff that makes up most of our actual world. Images, audio, and all that text. For that, we need something way more powerful. A technique inspired by the human brain itself.
Yeah, the big problem is that a photo of a cat isn't a neat spreadsheet. It's just a chaotic jumble of pixels. Traditional machine learning loves clean, structured data, so it gets really tripped up by the messiness of the real world. And this is where deep learning comes in and completely changes the game with something called a neural network. Just think of it like a detective agency that specializes in finding koalas. On the first floor, you've got the specialists. Their only job is to spot simple clues, a fuzzy ear here, a black nose there. Then, on the second floor, you have the middle managers. They take those simple clues and combine them into concepts like, hey, a nose plus two ears, that looks like a face. And finally at the top, the CEO looks at all the evidence and makes the final call. Yep, that's a koala.
Right, but that begs a pretty big question, doesn't it? How does this team get better? How does it actually learn from its mistakes over time?
Well, it's all about feedback. The super technical term is backward error propagation. But honestly, all it means is this. When the network gets it wrong, say it calls a cat a koala, a little error signal gets sent all the way back down through every layer. Every single specialist and manager gets a tiny note that says, hey, that was wrong, tweak your approach a little. And after doing this thousands and thousands of times, the entire team becomes incredibly accurate.
So, this amazing brain-like ability to understand all that messy, complex data, well, that's what directly unlocked the next massive leap. AI that doesn't just analyze the world, but can actually create brand new things within it.
So at the very heart of models like ChatGPT is this idea people sometimes call the stochastic parrot. After being trained on basically the entire internet, these large language models, or LLMs, get ridiculously good at one simple task, predicting the most statistically likely next word. So if you type, the cat sat on the, it knows from all its training that Matt is a super probable next word. It doesn't understand what a cat or Matt is, but it's a world-class expert at recognizing the pattern.
And that one seemingly simple skill, just predicting the next piece in a sequence, is what has powered this incredible explosion of creativity. I mean, look at this. We now have specialized models that can generate text, photorealistic images, stunning video, and even music, all from a simple sentence you type in.
So here is the most crucial point to get. While the older forms of AI were all about analyzing the world, classifying an image or predicting a price, generative AI is about adding to the world. It creates something totally new that didn't exist a second ago. The big shift isn't from dumb to smart, it's from analysis to creation.
Okay, but what happens when you take these incredibly powerful, creative AIs and you give them hands? The ability to not just talk, but to actually do stuff in the digital world. Well, that's where we are right now. We're entering the next horizon, AI agents.
Let's make this super concrete with an HR bot. At level 1, it's just a simple chatbot. It can look up info in a PDF and answer basic questions. Pretty reactive. Then, at level 2, it gets some tools. It can connect to other systems to, say, check your vacation balance. But level 3 is the giant leap. You give it a complex goal like onboard the new intern, and it creates and executes the entire plan itself, scheduling meetings, ordering a laptop, setting up accounts, the whole shebang.
You see, the one thing that really makes an AI an agent is that word autonomy. You're not giving it step-by-step instructions anymore. You give it a high-level goal, and it figures out the how all on its own. It plans, it reasons, it uses tools, and it makes its own decisions.
So here's a good way to think about it. If generative AI is this incredibly powerful engine that can create almost any content you can imagine, then agentic AI is the whole car. It's the thing that uses that engine to actually drive somewhere and get a job done in the real world.
And this chart really pulls it all together, doesn't it? It shows the whole journey we've been on, this ladder of autonomy we've been climbing. We've moved from simple, reactive bots all the way up to these proactive agents that can actually get things done.
And just so you know, when you hear people talk about an agentic AI system, it just means a setup that uses one or maybe even a whole team of these advanced agents working together to tackle even bigger and more complex problems.
And that brings us right here to today. We've gone from teaching a computer how to tell a cat from a dog to empowering it to reason, plan, and act completely on its own. It's pretty wild to think about. Which, of course, leaves us with one massive question. What goals will we decide to give it next?